Management and Decisional System – Methods of Machine Learning. In this video, we'll talk about the factors which need to be considered when choosing a machine learning method. At the end of this module, you will be able to analyze a given problem and to list the steps which are required to select and implement an appropriate machine learning method. Let's start with an overview of the required steps in order to implement a machine learning or ML method. First of all, a careful analysis of the given problem needs to be undertaken. These questions have to be answered. What is the objective of the study? How to choose the input data? Which type of data is to be analyzed? Then, the actual implementation of the algorithm is carried out, which comprises the following steps: data pre-processing, feature extraction and feature selection, selection of the learning technique, and selection of the algorithm. Now, we will discuss in more detail each of these steps. What is the objective of the study? Typical categories for an objective are pattern recognition, optimization, forecasting, modeling, and simulation. These objectives apply in particular if no analytical solution is available, for example, due to a very high complexity of the problem. How to choose the input data. For this purpose, the possible impact of different input data on the output is analyzed. This can be made by, for example, a correlation analysis. Only in case of a correlation, the respective input data needs to be considered. Which type of data will be analyzed? It can be either structured data, meaning data that fits into tables, unstructured data, meaning images or voice recordings, or a combination of structured and unstructured data. Sometimes, the type of data already determines the machine learning algorithm. For example, in the case of very complex data, particularly images or videos, an artificial neural network is usually applied. Data pre-processing. Firstly, the quality of the input data needs to be improved. This comprises data smoothing, data normalization, meaning bringing the data into the same value range, and data cleansing, meaning deletion of missing or implausible data. Feature extraction and feature selection. Often, the available data contain a lot of unnecessary or redundant information and is therefore difficult to handle. The desired results are much easier to obtain if certain features representing the essential information are derived from the data. Usually, the input data is transformed into a so-called feature space. This includes transformation from time domain into frequency domain, calculation of statistical indices such as mean value and variance, derivation of a new time series from two input signals, for example, convolution, cross-correlation, and autocorrelation. Selection of the learning technique. Each machine learning algorithm consists of two phases: the learning or training phase and the validation phase. While the validation phase is very similar regardless of the algorithm, there are three qualitatively different kinds of learning, which are unsupervised learning, reinforcement learning, and supervised learning. In case of unsupervised learning, only the input data is given but no feedback on the results. It is the biologically most plausible method, but not suitable for all problems. In case of reinforcement learning, the output of the machine is assessed by either a reward or a punishment. This means that a value is returned to the algorithm indicating whether the results were right or wrong. It is the typical way a child learns. Supervised learning, however, is the most effective way of learning. In this case, the correct or desired results are given along with the training data. The actual results are compared with them and the difference is returned to the algorithm. Selection of the algorithm. If the problem can be described as a complex, multidimensional and nonlinear function which is to be approximated, an artificial neural network is an appropriate algorithm. It is universally usable for almost any kind of problem. However, it can be difficult to find a suitable network design. Furthermore, training is very important in order to achieve reliable results. Often, a supervised learning technique is applied. If the problem is defined by a probability distribution of the result variable, the so-called Bayesian statistics can be applied. The idea is that an initially assumed distribution is updated and therefore improved with each new dataset that becomes available. Instead of a complex function with all possible influencing factors, the uncertainties are modeled by means of that probability distribution. Another approach involves the grouping of data based on similar characteristics. It's usually applied in the area of pattern recognition. There are two subcategories. If the groups are already known, a supervised method is used and the algorithm is called classification. However, if no information about the data is available, only an unsupervised method can be applied, and the grouping is called clustering. To sum up, the choice of a machine learning method depends mainly on the given objective and the input data. The first step is always a careful problem analysis. After the required input data is identified, the implementation can start. It consists of data pre-processing, feature extraction, and the selection of a suitable learning technique. Finally, the learning algorithm is chosen and implemented. Thanks for watching.